Hello, and welcome to the March 21st edition of the Cluster API Working Group meeting. That's part of SIG Cluster Lifecycle. The first couple of agenda items today are from Chris Nova, who I believe is not quite here yet, but I think we can go through them in her absence. So the first one is owners for the new repository. So this is referring to the new GitHub repository that's been set up in the Kubernetes-SIGs organization, which is new, and as last I checked, only had like 3 organization members, which is frustrating because it means if you're not an organization, you can't do things like use the bot to assign or close issues or add labels, as I found out to my chagrin. Yeah, so we need to figure out who is going to be owners of that repository. So I asked her how we get added to the org. It looked like she got added to the org because she was able to close an issue. But it's not clear to me how other people are supposed to get added to that org. I haven't seen sort of like a new members document the same way there is for the normal Kubernetes org. Yeah, right now it's just Brian Grant, Michelle Norali, and Aaron Krickenberger are the only people in the Kubernetes SIGs org at all. So yes, so we need to figure out owners for the repository and figure out how that's going to work. But we also need to figure out how to get people added to the org. Does anybody on the call happen to have any information?
I did think we were trying to use bots to avoid org permissions entirely. So it would be the owner's thing rather than the GitHub org permissions.
Right, but you can't use the bot if you're not a person in the org. So we have to be in the org even if we have no explicit permissions. Like you're not necessarily in a group within the org that has extra rights, access to the repo or anything. Does that make sense?
Just to clarify on that, you can use the bot if you're not in the org. The bot can't do certain commands to users that aren't in the org. Like a non-org member can't own an issue, which is what you tried to do.
Well, I tried to close it and told me I couldn't close it. So I tried to assign it to myself so I could close it, and I couldn't assign it to myself either.
Yeah, only authors and org members can close, and only org members can be assigned to it. It's not, you can't use the bot if you're not an org member. They're just
okay. But I mean,
on bot commands.
We need to be able to do like issue management in that repository, which we can't do right now because nobody has access to those issues. Right.
Yes, I would argue that
the author of each issue to like triage that issue. That's kind of ridiculous.
Yes, I would argue though that being an org member to manage issues for the organization is a decent requirement. Like there are other commands like rerun test or something that you don't have to be an org member for.
Are you sure? Because I've definitely seen pull requests come into Kubernetes where it says someone from the org has to write OK to test before we'll run tests on your PR.
Yes, once it's OK to test, you're allowed to rerun the test though.
Okay. That means that right now, if any of us sent a pull request, no tests would be able to be run against it either.
Yes, we should put members in the org, but for like general contributors who want to come from outside, they have a lower privilege level access to the bot commands is all I'm saying. Sure. But we should definitely fill up this list so that we have rights we want.
Okay, since Chris isn't here, I'm going to assign an action item to her to follow up on this. In terms of owners for the new repository, does anyone have a suggestion or recommendation on how we pick people to be owners of the repository? The only thing that I had suggested so far was when Aaron was going through and setting up owners files for all the existing repositories, he set up owners aliases so that SIG leads would own all of the SIG repos. So like, Lucas and Luke are owners of the current kubedeploy repository, even though they're not actively working on kubedeploy, as sort of an escape hatch, to help manage that if there's turnover, we need to add other people. So that was the only thing that I knew that we should definitely seed it with. Presumably people that are active contributors, we should also be sticking in owners files also. But does anyone have like a good sort of process for figuring out who those people are or nominating people? I don't know if there's anything in Kubernetes we can steal off of for that.
There used to be a ladder, I think, with fairly strict definitions. I think it's been very much relaxed, and now we can do whatever we want. It does make it awkward if someone, like, the sort of self-submit a PR can be sort of like not having guidelines makes it harder, in my opinion. But we should probably make everyone that has got a PR merged reviewer. How about that as a starting one? And then the approvers, I don't know how you want to do that.
That seems like a reasonable suggestion. I'm going to put that into the doc. Obviously, we should let people opt out of being reviewers too. If they merged a PR but they don't want to get PRs assigned to them by the bot, they might not want to be a reviewer.
It would also be nice to have broad representation across the various organizations that we all work for.
Yeah, I think that's why Chris was trying to figure out how we pick people to be in the owners files, right? Okay, so the next thing was a migration plan from the current kubedeploy repository for the pieces we want to pull out that are cloud or environment independent to put them into the new repository. Following the discussion a week or two ago, Chris opened an issue to talk about how we should do this. There's been a little bit of discussion on that issue, sort of coming up to my suggestion that we can keep debating this, but we should probably just move forward with what we think is reasonable now, and then refine later to make forward progress. And Chris asks, should we just open a PR or write a proposal? And I put a comment in the doc yesterday when I was reading the notes for this meeting, basically saying, if it's simple, we should just write a PR. If it's complicated, we should make a proposal. So I would propose that we just make a PR, and if it seems controversial or too complicated, then we should go back and do a proposal to try and avoid as much red tape as possible. Does anyone believe that it's going to be more complicated than just moving a bunch of files?
Yeah, I think it'll be slightly more complicated. Part of it depends, I guess, on one of the agenda items of whether the change I have out for review of whether we think that's the right way to go forward. Because until something like that happens, you'll be pulling in cloud-specific code as well, or else it won't build. And then also, there's some test infra stuff to turn up, but that's going to be some backend stuff. It doesn't have to happen at the same time in the migration, but I don't want new changes to go into the repo without that being turned on. So we at least get build and test status, so no one breaks the build. But other than that, I don't see any complications.
Okay, I mean, that sounds straightforward enough to me that we probably don't need to write the design doc for it, unless, as we go down the agenda item, that your proposal down there for more strictly breaking out the Cloudflare stuff is really controversial. We need to do that a different way.
One comment here is because the original code was built using the API server builder. He assumes some directory hierarchy in that sense, in terms of where is the controller, where is the API. If we want to make separation here, I think it will be some trouble. I think not something we cannot fix. I think just bear in mind there will be some cost here. So, maybe going forward we can no longer use the API server builder.
Can you clarify what you mean by, so it expects the directory structure, but presumably would have that same directory structure in the new repo as well?
But I thought that the idea was just, for example, only pull the API over. We don't pull the controller over. If that's the case, that's the implication I'm talking about.
Okay, yeah. So I think my proposal was, for now we don't bother trying to separate those out unless people need us to, because it's causing a lot of pain.
In that case, it will be very simple. If we move everything over, simple, no problem.
Okay, yeah, because I think that the arguments for splitting it apart today were that people wanted to be able to build other controllers outside of the main code. And I think people that are doing that are likely to want to be able to pull in some of the other code in addition to just the API, so they can have reusable libraries for doing watches and have the machine set to controller and so forth. I think that my argument for having the API separate was more that client-side tooling that wants to depend upon the API, not to implement the API, they don't care about having the controller implementations. They probably maybe want client implementations, like they might want the client Go equivalents, but they don't want the machine controller, right, code to be vendored into their repo. And I think that's where we might see some demand for splitting them up. But again, we're not there yet, so we shouldn't complicate our lives until we need to.
Yeah, agree. I think it's a fun plan.
So Chris's next agenda item related to the repository migration is about issues and whether we should migrate existing issues. And she was wondering if she should just groom issues in the new issue tracker. I pinged Rodrigo about this yesterday, since he's also been doing a lot of issue backlogging and grooming. And his take, which I tend to agree with, is that any issues that are specific to the API, we should put in the repo with the API. Issues that are specific to the code that's in that repo, we should move over. And that issues that are specific to the Google implementation that's in KubeDeploy right now, we should just leave alone. But generally, the issues should live in the same repo as the code.
Yeah, I believe we have a label for GCP specific ones. So we need to make sure that list is accurate, and then you should be able to copy most others out. Or make sure the cluster API tag is on the issues we care about and just worry about those.
Right. And I know Chris was going to groom the backlog, and this is probably a good opportunity as we move them over to sort of do that grooming and make sure that the right things are tagged for stable API and alpha or beta or however else we're sort of demarcating milestones going forward. All right, so there are other comments there. So the next one is machine class. So that we've talked a number of times in the past about having machine classes and being able to, basically have sort of a template, if you will, just to stamp out new sets of machines or new machine deployments, referencing based on sort of a simple string name, so that when you are saying, give me a new machine, I want a small machine, or whatever that generic name is. You don't have to specify all the provider config. So I linked to a PR here where I split the provider config into a struct, while also changing it from a string to a runtime raw extension. Now that there's a struct there, there's a hook where we can plug in a reference to a machine class instead of directly embedding the provider config in the runtime raw extension field, which is what we do today. And so I'm actively working on some prototype code to do that. And I have a meeting with Saad from SIG Storage right after this meeting to talk about storage classes and make sure I'm not going down the wrong path. Like I said, one of the main goals for doing this is to make sure that it will work with auto-scaling, because the way that the code is written right now, the autoscaler doesn't really have any hooks to plug into to figure out, if I scale this machine set, how much capacity am I going to get by adding one node or adding 5 nodes? How much is going to be reserved by node allocatable? It does have the hooks right now to figure out labels and taints, which is sort of the other half of the picture that it needs. So I think the most important fields to put in the machine class itself are capacity and allocatable, because those are the things the autoscaler needs to function correctly. I'm trying to kind of keep everything else in the cloud provider specific reference from the machine class, so that the machine class itself can be relatively small and sort of serve the purpose for that piece of automation. So again, that code is being written and prototyped and tested at the moment. And hopefully I'll have an update or a PR to send out before next week's meeting. Questions, comments, concerns?
Hi. So I think previously when I joined, there was a discussion happening that at which layer we should add the machine class, right? So and the suggestion and consensus, I think at that time was it should be at all the layers. There should be a flexibility to edit all the layers. So just verifying what's the...
Yes, that's a great question. So I went back, I was actually not at that meeting, but I went back and read those meeting notes. And I think that seemed like a reasonable answer. And so the way that the provider config got broken out, it's broken out at the lowest level, at the machine level. So at the machine level, you'll be able to either reference a class or inline provider config. Machine sets use a machine spec as their template. So they inherit that behavior of being able to reference out or inline. And the machine deployments, I think, will inherit that also. So yeah, we'll be at all 3 layers.
Okay, that's great. Yeah. And from the auto scaling perspective, so I'm not very sure. So we are actually currently trying to integrate cluster autoscaler with the machine controller manager, which was previously known as node controller manager, right? And I mean, we changed the name to machine. So what we have understood that cluster autoscaler is exposing a certain interface. So they call it a cloud provider interface, and there are certain methods that we need to implement for different providers. And I was checking out how AWS is doing, and so more or less what I could understand is that cluster autoscaler currently just manipulates, in the case of AWS, let's say, the target size of the ASGs. So it's like AWS autoscaling groups, right? So in the same way, what we are doing is we are just plugging in our machine deployment at the moment. So it's like autoscaler will just play around with the replicas field of the machine deployment, modify the deployment whenever it's needed, and that's how it should just work. So I'm just not sure how machine class will have effects there.
Yeah, so let me go into that a little bit. So we talked with Marcin, who's one of the tech leads for SIG auto scaling, and he was telling us, so they have this cloud provider interface, but that's not particularly flexible, because it means that that basically new code that wants to be built into the autoscaler has to be put in tree. And one of sort of the pushes with Kubernetes is to make things more composable and to not have to put all of the code in the same location. And in particular, they had someone submit PRs and added an Azure implementation, but then nobody was supporting it. So they actually had to take it out of their repo. Whereas if they had a more composable way of building an autoscaler, then the Azure code could live somewhere else and somebody else could provide support and updates for that without having to send them PRs. And so they were looking at basically, instead of extending that cloud provider interface, of getting rid of it entirely and saying, instead of saying, I'm going to call out to Amazon to scale an ASG by 1, I will use the machines API to scale a machine set or a machine deployment by 1. But the thing that they do with MIGs on GCP and ASGs on AWS is that they actually call out to the cloud provider and say, what size machine is this? How many cores does it have? How much memory does it have? They, at least on GCP, they read from the metadata about what labels and taints are going to be on the machine and how much capacity we've reserved through node allocatable for that machine. And all of those different bits get plugged into the scheduling algorithm that they run to figure out, if I add a new node, will it actually allow the pending pod to be scheduled? And so from their point of view, they're having to do like they have some special code that I broke 2 weeks ago on GCP that reads specific values out of the metadata that we, from the cluster lifecycle point of view, think of as an internal interface that nobody should be depending upon, but they are depending upon it. And so the machine class gives them an actual interface that they can depend upon, where we can expose this data in a standard way across different implementations. And that means that you don't actually have to go change the autoscaler code if you want to add support for DigitalOcean. All you have to do is add the machine controller for DigitalOcean, set up some machine classes that expose the values that the autoscaler needs, and the autoscaler should just work. And that allows the autoscaler to basically rebase. Instead of having cloud provider code, they should eventually be able to delete all their cloud provider code, just talk to the machines API, and work anywhere that the machines API works. And so we're talking about them on how they can get to that eventuality. So instead of us plugging into the cloud provider interface that they have right now and saying, we're going to add a cluster API hook into your cloud provider, we want to flip it on its head and say, the autoscaler will call out to us and we will provide sufficient information to drive their algorithms. And then anywhere that the cluster API is implemented, you can run autoscaling with no extra work to be done.
Yeah, that sounds good.
So yeah, so the main goal of the machine classes, from my point of view, is to write some prototype code, verify that it looks like it serves some of the use cases we've talked about in this meeting, and then go back to SIG autoscaling and say, this is what we've got. We think that it will work for you. Can you verify that it's good enough, right? And that's, to me, sort of the bar for it sort of passing muster. Is we know we want it to drive autoscaling. If it can't drive autoscaling, it's not sufficiently descriptive.
Okay. So the developments from the auto-scaling groups, right? So that should come only after we go stable with our at least machine set or machine deployment APIs, right?
Yeah, and so Marcin
that's-
has been pestering me for the last couple of months saying, when are you going to have a stable API? When can I start writing some code? Like, when's this going to stop changing, right? And so they're very excited to start trying to rebase their code against the machine's API.
Okay.
So yeah, so that's.
Oh, sorry.
Oh no, go ahead, Martin.
What about existing customers of the cluster autoscaler without the machine control thing? So
yeah, I mean, they're certainly not going to just like completely rip out all the old code on day one, right? I think it'll be a gradual migration, but it will allow them to support new environments without having to add new code themselves. And as we take existing environments and move them over, they'll be able to sort of get rid of some of the old code. And maybe the project will fork and we'll say, here's one where if you still want to talk to MIGs or ASGs or whatever, you can use this code. And if you just want to use the machine's API, you can use some different code. Maybe it'll end up forking. I don't know what their plans are for maintenance of the old stuff. But yeah, they're definitely not gonna do a knife switch and drop all the old support immediately. But I think it gives them a clean path forward to saying, this is great. We no longer have to talk to any infrastructure. We don't have to worry about vendoring cloud libraries. All we have to do is talk Kubernetes APIs, top to bottom, and we'll work in any Kubernetes environment. So I think that's pretty appealing to them, they can get themselves out of the business of talking to underlying infrastructure.
Question: with machine classes, how it will handle like special needs? For example, if a machine provides a device like accelerator or something like GPU, FPGA, something like that.
So you can do that today in the provider config, right? So in that provider config struct, you can define your schema so that you can express things like a GPU or an accelerator. So I think the tricky thing is how we express that in a generic enough way that the autoscaler can be driven off of it. Or if you say, I'm trying to schedule this pod, it requires an accelerator. How does the autoscaler know from the machine class that creating a machine of this type will give me an accelerator? And I think the way that the way that I'm looking at doing the classes, there is let's see if I can find it. There's something called a resource list in the core V1 APIs. And so you can basically say, what are the resources that I need? And I think we might be able to leverage that as part of the capacity of your machine class. And so the machine class will basically say, like, here are the resources I provide, whether that's memory, disk, CPU, GPU, accelerator, et cetera, and that's a list. And then the autoscaler can match up against that list of resources when it's trying to figure out what will be provided from the underlying machines.
What about not so obvious resources like network cards and, for example, like NUMA nodes?
So, I think, so for special resources like this, you're going to have pods that want to use them. And so the scheduler has to be informed about how to make sure to match up that pod with the right machine. And so we should really just take a key from however the scheduler is doing that constraint matching and represent it the same way, whether it be via resource list or if it's a special one-off label or something like that. I think we should just match however the scheduler represents that constraint.
Yeah, that's a good point, because the cluster autoscaler like literally vendors in the scheduler code and runs the scheduling algorithm. And so what it does is it says, I'm going to pretend to add a new node, and I'm going to try to model that node as best that I can based on what I know about the cloud platform, and then I'm going to run the scheduling algorithm against it. So as Chris was saying, if the scheduling algorithm doesn't take these things into account, then the autoscaler is also not going to take them into account, and so it's not something we need to represent. And in particular, I think that things like network interfaces is not something that's represented in the scheduler, at least not today. Whereas I think GPUs are either directly or indirectly represented. They're either a direct resource or they're indirectly represented via labels. Because most people who are going to create machines that have GPUs are likely to label those machines so that they can make sure their GPU workloads are pinned They might even taint them to make sure that they're not wasting those machines on workloads that aren't taking advantage of the GPUs. And so based on the labels and taints, which are the primary workload steering mechanisms, I think that is often enough to inform the scheduler and the autoscaler to do the right thing.
Yeah, my worry was just when we are describing the machine, it should be flexible enough to accommodate all kind of these extended resources, even though it's not used by autoscalers.
Yeah, and that's where I want to talk to the autoscaler folks, and maybe I should talk to the scheduling folks too about this. My understanding, or my hope maybe, is that the resource list is sufficiently expressive that it allows new resources to be added in the future that will just sort of automatically be able to be used in the machines API as they get added to the core of Kubernetes. And that is what would be driving the scheduling decisions, the cluster autoscaling decisions, and then you'd be able to represent that in the machines API. So that's definitely something I need to validate that assumption.
Since we're talking about resources, have we, was it discussed at some point to map or somehow have the some piece of code map the resources to what the kind of a provider config would look like automatically, maybe as part of this API to the provider itself? That way the user would just generically specify CPU, RAM, whatever, disk sizing and whatnot, and the providers would know what to provision versus having to figure out manually how to map, AWS instance types to sizes and things like that.
Yeah, that's something that we talked about pretty early on, at least internally. I'm not sure if that was something we talked about in this meeting publicly, was basically being able to say, I want a machine with these resources, and then allowing the underlying cloud provider to sort of do a best fit match. So if you said, I want 3.5 CPUs and a gig of memory, that might not be possible to do in all platforms, but you might round that up to 4 CPUs, and you might say, AWS, if I have 4 CPUs, only supports 8 gigs of memory because they want to have the right ratio. So if you ask for 3.5 CPUs and a gig of memory, I'll give you 4 CPUs and 8 gigs of memory. That's the best fit for your request, and I'll provide that machine for you. That's not something that's currently modeled in the Machines API, and was not sort of the primary goal for the machine classes. But it might be something we want to talk about, is how we would sort of model here's a set of requested resources, and then allowing the underlying implementations to deliver sort of their best fit for those resources.
Fair enough.
I think that's a separate discussion from classes, but maybe there's a way to have the classes solve both of those.
Yeah. One thing, I guess, in Bosch, the way we've implemented this is we still kept the API to be, accept the provider, specific config, but we also added the API for the providers to effectively be able to convert the generic input into something more specific for them. So effectively keeping the basic API the same, but also kind of extending as an additional feature for this kind of a conversion.
Yeah, and I think that makes sense. And I think that's sort of the goal with the machine classes in some sense, is if we said, we're going to create, small, medium, and large machine types, then the providers, could map those to what they believe is small, medium, and large in their environment. And that makes their configs a little bit more portable, because you say, my machine's at config, it just says, I want small machines, I want 5 small machines. But I think it is a little bit of a leaky abstraction, because if you're going to move from Google to Amazon or to Azure, then you have to hope that small machine is about the same number of cores and has about the same overheads in terms of node allocatable and some of these other features. Otherwise, it's not going to be the right size for your cluster anymore.
Right.
But maybe something like autoscaling fixes that, where you say, like, I have this template, I want a bunch of small machines. I don't care exactly what they look like, because the autoscaler will kick in and give me the right number based on my workload. So we do have that sort of thing we can fall back on too.
Do machines classes typically get populated by I guess an operator, or by some more automated process that may be even shipped as part of the the provider?
Yeah, that's a great question. So the way that it works for storage classes is the provider can seed some storage classes where they say, we're going to set the default storage class on GCP, which uses standard PDs. But then cluster operators can go add more storage classes, and they can reference those, and they can even change the default. So with machine classes, what I was sort of picturing in my head was, when you launch your Google Machine Controller, it might automatically create some number of machine classes that it thinks are sort of common sizes of machines that people would want to use, and registers those automatically. But end users can then always create their own machine classes and map those to arbitrary other underlying resources. But those machine classes would only exist in clusters where they have created them. So their workflow for spinning up a new cluster might be create a new cluster, now add all my custom machine classes, now spin up my machine sets, because I have specific ways that I want to configure my groups of machines. Does that make sense?
Yeah. Yeah.
It's kind of a combination of both, right? It's definitely going to be configurable by cluster operators, and we will likely want to seed at least some default machine classes based on the environment that you're running in, based on which machine controllers you're running. They'll probably just say, if machine classes don't exist, go ahead and set some default ones for people to use.
I see. That makes sense.
This has been a great discussion. Anything else on machine classes? All right, Chris Razzie, you're next.
Sorry, I was zoning out. What's mine? Oh, yes, the PR.
Yes, your PR.
So I've gotten some feedback that there have been some hesitations about modifying the generated code. But it does break the dependency. I was wondering, what is the overall consensus on this? There's some more work to be done with building the new Docker images and changing at least the GCP deployer to deploy properly with the split apart controller. But I was just wondering, it modifies 2 generated files that are only specific to the controller. It doesn't change anything about any of the generated API code or client code, which I think is the high churn stuff for generated code. Like you add a field or you change a field or something like that, that will need to be regenerated a lot. So I was wondering what everyone's feedback, or if they got a chance to look at it, what everyone's feedback was and whether we should move forward with that.
I had a look at it. One problem right now, if you look at the Kubernetes, you have there the container network interface. You have the container runtime interface, and I was thinking maybe approach like this is the best way to go. So you can have, for example, in one pod, you can have the machine controller into one part, or the machine controller manager, or that encompasses the deployment, the set, and then the actual machine. And in the another container, you can have only very small piece of code that will implement this machine runtime interface or whatever. So by breaking dependencies, it will be easier, I think, because right now with this approach that you were suggesting, everyone has to write their own controller, and in most cases, people simply want to create a machine, not to implement the entire controller.
Everyone has to implement their own main for a controller, but I'm trying to navigate my change right now, but if you look at my controller main, it's basically 67 lines of code that mainly reuses libraries, but only make sure to use the machine controller library with the Google interface plugged into it. So this interface has to be written for whatever provider you're on, whether it's AWS or Azure or anything like that. So there's no getting around writing that, but the glue code to actually plug them together is not that much more. And it also allows you to have flags per machine controller, so we don't have things overriding, like we want to add specific config options to the GCE machine controller that I'm sure AWS or Azure would not care about. And so this gives us an entry point to also do more customization for specific provider controllers as well. You're right, most people just want to create a machine. This change should not affect that in any way. They just have, instead of deploying an API server, etcd server, and controller manager pod, they have an API server, etcd manager, controller manager, and machine controller pod. It just adds another pod that hopefully someone else writes for them and maintains. And the API interface, as far as like the cluster API, should be exactly the same.
Okay. Well, I'll try to summarize my things, my thought process into like a comment, and then I'll just send it.
To get a preview of your thought process, Martin, are you thumbs up, thumbs down, or kind of on the fence about this direction?
I mean, yeah, I mean, after writing several controls internally at SAP, I mean, it's there is a lot of boilerplate that you have to write in order to get like a fully functional controller. You have to write like, for example, leader election, signal handling, and all those kinds of things. And if those things are already implemented into this like big controller manager already, and you only have to care about simply creating the machines and without handling any reconciliation loops or creating informers and all those kinds of things. So I don't know, it's easier as an end user at the end.
I think leader election and stuff like that could be built into the controller library if you want. I don't think it's there now, but it's something that we should add to the generic controller library, I think. I don't think that should be brought out to the glue code part of it. And the only thing the controller library doesn't do as part of the controller right now is something called the machine actuator interface, which is creating, deleting, basically a CRUD interface to the underlying cloud API. The machine controller library still has like informer interaction and reconciliation loops and all that. The one thing that I had to do here that is boilerplate is I parse a config file into a struct, and I handle like a little startup errors, and then I basically create new shared informers so that I can pass the shared informers into the machine controller library, and that's the shared informer and the Google Machine Actuator into the library, and that's it. And my main motivation for doing this was twofold. One, breaking out the controller library's dependency on Google stuff, and also making it easier to add custom configuration to the Google Machine Actuator, which is something we want to do. And not pollute the overall library, just plumbing through Google-only options.
Do we foresee these controllers being in separate repos in the future? Yeah.
Yes, I think this is actually one of the main things we want to accomplish before we move to the new repo, so we don't have to move all the Google-specific code too. Like, we want that to be devoid of any interaction with the GCE API.
Yeah, and Chris Nova explicitly said, I'm not going to move any Google code to the new repo. And as it is today, if we move code without any Google code to the new repo, as Chris Rousey mentioned earlier, that code will not compile at all. And so it'll be really hard for someone else to build a controller because they'll be vendoring in code that doesn't compile.
So I looked at the PR and I was surprised that the generator code is generating any controller bits that you have to change. I mean, it seems like you could say you don't want a controller to be generated. That's it, or some way, right? But yeah, it's a +1 for me. I think it should be separate.
Yeah, by default, the API server builder generates a lot of code. It generates deep copy code for the API types, conversion code. It generates client code, including informers, which is very useful. And it generates a controller kind of like stamped out template that does nothing. And the one thing you have to modify is, like for the machine type, it generated a machine controller framework that had a machine impl struct that you were supposed to fill out. And so it basically gave you a controller framework that you could build on for the machine controller. And what we did was we built a machine impl. We built on machine impl for a reconciliation loop, and for interacting with the API types, we left a lot of the common code in. But when it came to actually doing CRUD operations on the cloud, we put that behind an interface called a machine actuator. And then we wrote a Google machine actuator to satisfy that interface. And then we put a hard dependency on the machine actuator through a factory function, which is what this change is breaking that dependency through a factory function.
So if you run the generator again, will it overwrite your changes?
If you rerun the controller generation, it will overwrite these changes. And then you'll get a build failure because it won't build.
So would it make sense just to leave the stub controller in there and have it do nothing, and you just, have the separate controllers that actually do stuff?
Unfortunately, the reason I had to modify the generated code was I had to modify the machine impl or the struct that it stamped out, and its initialization now takes another parameter that the generated code does not call. It tries to call it with one less parameter, so the generated code would no longer build, even if I didn't modify it, it wouldn't build.
I see.
So yeah, the main change was, instead of the machine impl calling out to a factory function to get its actuator, just have the actuator passed in.
Yep.
I have a question. So when you're talking about custom flags and etc. to the Google, for example, controller, are you referring to flags specifically for the controller, or that you relate more or less to the actuator? So
Stuff that relates more or less to the actuator. One of the biggest flag is just going to be a config flag. That's going to be a parsable config. We're going to back it by a config map, and right now we're thinking about having like a supported bundles. Like if they request like Kubernetes 1.10 with say on Ubuntu, this is the actual GC image, and this is the actual installation setup script for that. Whereas we can now, with that, we could support like a 1.9 setup method and 1.10 setup method if they're like slightly different things that need to happen for that. It's just future proofing, for one, having flexibility with versions, also allowing users, if they want to change how it's installed slightly, or even bring their own OS, like if they want to create a SUSE Linux image and want to own how to set up a node for that, they can specify it through this config map. It's something that might be useful to other people, but it's also going to have very GCE specific stuff, like here's a GCE base image to use like a API path to it.
Yeah, I presume we'd also use those flags if we need to plumb through like authentication, authorization bits into the actuator as well.
Yeah, one thing that we might want to do is like defer, like we want to have a custom certificate signer and not have the machine controller have access to the cluster private key. We want to may have an API endpoint to defer the signing to some other trusted source. And maybe an interface to back that with Google Key Store or something like that.
yeah, but this specific logic will happen in the actuator or in the code that is around the controller, if it's not proprietary, whatever.
I think it would happen in the actuator. Anything we feel is common enough for everyone, we would probably want to promote upstream. And there may be some things like that that we want to experiment with at first on Google. And once we like get the use cases down and see that, okay, we made a mistake here, but we can change it, and then get a decent use case down, we'd probably bring it to the community and say, would this be useful in the generic library?
Yeah, I mean, because the generic library is calling out to the actuator to do CRUD, right? Create this machine, delete this machine, update this machine. And the actuator is the thing that's actually talking to the underlying cloud. And so that's where you need to configure that actuator to do that correctly.
Yeah, great. One was concern is with this approach, we are only limited to Golang, basically. Yeah.
Yes, if you want to reuse the libraries, you're limited to Golang. You can always write your own controller that you run instead of this controller in any language that you want. But I think that's going to be, I guess if we followed your approach of sidecar container with specific hooks, then you could reuse the controller logic, and that interface becomes basically an RPC between processes, right? And that would be a little bit more flexibility.
Yeah, this is my original idea, like a gRPC or something like the container runtime on the container network interface.
Yeah.
Yeah.
The big downside I see of that is that both CNI and CRI and CSI are going through very long, convoluted sort of standardization processes, which I don't think we want to do right now. And so I think doing it in process now, and if we find we need to break that out later, that seems like a task we could take on later, which is what we did with container runtime, right? Like initially the kubelet had built in direct support for Docker, and then they decided we want to break this apart. Let's now take on the large task of breaking it apart. That is probably a better approach so we can actually get something done in the short term.
Yeah, and at least this in-process binding isn't forced upon you. You get to choose what's binded. Or bound, I should say.
Yeah, it's great.
Yeah, so there are concerns for the modifying of the generated code. One person maybe volunteered to update the API server builder. I'll respond that this may be something we want to go through if they wish to upstream the ability to customize this generated code a bit, so it's not an issue. But from what I'm gathering, this sounds like a thumbs up. If Martin, you want to put your feedback on there before we move forward with it? I still have a lot of things to do. I'm basically writing make files and changing. I basically still have to write make files and change the GCP deployer to have a different deployment to account for the extra pod. But other than that.
Cool. Yeah, I think this would be great to get in so that we can unblock migrating code to the new repo too, once we figure out owners and all that stuff.
Yeah.
All right, we got 10 minutes left. There's one final agenda item, which is also from Chris Nova, who's on here, which is asking for an update on machine deployment. So I don't know if anyone here can provide an update on machine deployments. There have been some initial design docs sent around, I think, mostly from Messam, from our side. And then obviously, the SAP folks have the machine deployer in their machine controller manager as well, as sort of a base that we can build on top of. But I don't know if there's any concrete updates that people can provide on getting that upstream.
So we have, sorry, I have not been able to check the architecture for the machine deployment, but one hint on that we recently found while integrating autoscaler that we will require from the machine deployment. So basically autoscaler expects that under the machines which are under a certain machine deployment, so we should be able to delete a specific machine, and at the same point in time we should be able to decrease the number of replicas of the machine deployment as well. Right, so these two things should happen in parallel. So if we are having a standard approach of just scaling down blindly, then internally we may end up. Initially we end up doing the things like the machines with running, pending, and terminated, we give higher priority to the terminated machines to scale them down first. So that's where a new logic would be required. And what we did, we can have a new annotation for a priority. So we just basically assign the priorities to the machine objects, and we expect either autoscaler or a certain other component to actually put a priority annotation on the machine object, and then machine deployment takes that priority number as an input and then tries to delete those machine objects first before the other machine objects. So that might that's just one heads up that we found while integration of the autoscaler inside machine deployment code.
Yeah, that's a great point. And that's actually something that the autoscaler folks mentioned to us as one of their requirements is I want to be able to shrink the set by a particular single or particular set of machines. And funnily enough, one of a GKE customer actually asked for that feature on deployments inside of Kubernetes as well, where they said, if I have a Kubernetes deployment or Kubernetes replica set, I want to be able to shrink that by a particular one also. Like they said, as a feature request, I want to be able to delete that specific replica and not have a race condition where I'm trying to delete it and shrink it and fighting with the controller. And SIG apps has not yet implemented that. So we might be treading some new ground there. But I do think that sort of feature request has also been asked for in Kubernetes itself, managing pods. So it doesn't seem unreasonable to just build that directly in.
Okay.
Is there a timeline when the first machine, like the type definition, is available?
That's what I was saying. I don't think anybody is actively working on trying to put a PR together for the types for machine deployment yet.
Okay.
If they are, they should let us know now, so we're not duplicating effort. But I don't know if anybody has signed up to do that quite yet, and B, I don't think anybody's actively working on it at the moment. I think it's sort of in everybody's head as sort of the next step after machine sets. But I haven't seen anything pop up that lets me think somebody's doing it quite yet.
But more or less, we will be replicating the types from the actual deployment itself, right? Just calling it for the machines.
I think for the most part, I think we'll, as with machine sets, we'll need to be careful to make sure that all of the fields apply in the same way, which in machine sets case, I believe that they did. And then, like as you mentioned, sort of making sure that these other use cases that aren't yet implemented for deployments or replica sets, that we have a way to express those in our API, which is hopefully consistent with where SIG apps will go in core later.
So I could just recall one more point there. So recently, then we also implemented the drain functionality. So before deleting a machine, so this could actually be a part of the machine set, and I'm not sure whether it is already there in the existing implementation in Cluster API. So we can actually leverage a nice feature from the Kubernetes itself. So long back, I think there was a conversation that when the ruling update is happening from the machine deployment, we also want to make sure that the applications running on top are somehow, we ensure that the applications are actually respecting the application SLOs. So the PDBs are being respected, right? So to solve that problem, rather than implementing it by ourselves, what we did is that before deleting a machine, we initialized the parallel drain functions. And as you could see, the Kubernetes itself, while parallel drain is happening, respects the PDBs of different applications. So it's really possible that if you are, let's say, scaling down 3 machines in parallel, and before scaling down those machines, if you are applying a drain function in parallel to all those 3 machines, then the applications running on those 3 machines are by default going to respect the application PDBs. And
I didn't quite catch you. So what did you initialize that caused the drain to respect the PDBs?
So before deleting any machine, so we by default in Machine Controller Manager, before deleting a machine, we execute the same drain function that we have in kubectl. So we basically copy the kubectl's drain function, put it inside before the delete logic, And what happens is that when I have a machine deployment with 10 replicas and I want to make it 5, basically 5 machines will be basically be going down in parallel fashion, right? So these 5 drains are happening in parallel, and because Kubernetes drain function is implemented in a way that the application PDBs will be by default respected, and that's how we can ensure that the application SLAs are also respected. So back then the conversation was that it can be very critical, very complicated to implement it, but it got resolved in much easy fashion.
Yeah, and there's also been a discussion about moving that drain functionality into the server so that you can just ask the API server to do it for you. Because right now, like GKE has implemented client-side drains, you guys have implemented client-side drains, COPS has implemented client-side. Like everybody who cares about this is implementing client-side drains on their end, whether they're shelling out to kubectl or rendering that code in or rewriting the code, which is a little bit silly. It'd be nice to just have that code written once that everybody can reuse inside the server, right? Because then kubectl drain can just say like, great, hey server, do the drain, and the machine, controller can just say, hey server, do the drain, and we don't have that code twice. So we can poke people and see if that's on the upcoming roadmap.
I've seen the issue, especially with the server-side draining, and everyone keeps asking about it, and nobody actually started working on it. So I don't know. It looks like the best approach is to have a separate source on the node, probably, or something like this, and then you send like a request. Yeah, we should. I don't know which approach is actually better, to implement it to implement it and then go to the API machinery, or which should be responsible for this one. API machinery, cluster, SIG node.
I would say apps for workloads. Since it has to deal with rescheduling apps and workloads off of a node and respecting their SLAs.
Yeah, I mean, maybe part of the reason it's not making progress is because the ownership isn't clear. Because right now it's probably owned by SIG CLI, right? Because it's part of kubectl. But when it gets pushed to the server, I think it's a little bit unclear whether it's API machinery or workloads or scheduling, right? It has to do with scheduling also, and sort of who the owner of that becomes. So we can poke at people and try to see what the status of that is and if it's on anybody's near-term roadmap. Otherwise, we'll probably, like you said, end up doing the client-side drain for now and just saying that we will replace that in the future when server-side drain becomes available. All right, with that, it's now 11 o'clock.
One last question. So currently, no one is putting effort into it to create a first PR of the type definition. Should I or should we take care of this, creating a first type definition and then creating a PR, and then we can discuss on how it should look like?
Sure, that'd be great if you want to take that as an action.
Yeah, I will do.
Thanks. All right, thanks, Sebastian. I'll put an AI in the notes for you. And it's now a little bit past 11 o'clock. And so we're gonna go ahead and call this meeting over. Thank you, everyone. We've had I think a very productive and useful meeting today. A lot of good discussion, and hope to see everyone again next week. Take care.
Bye.